Before we start this lesson on the law of cosines, I want to take a second to look at a couple review problems to get us thinking in the right mindset going forward. So first, both these are on your notes. I want to give you a second here for you to try to do number one. In the figure below, line L and M are parallel. Transversals T and U intersect at point A and intersect M at C and B. Point X is on M, and the measure of ACX is 110. The measure, angle BAC is 40. How many angles formed by the rays LMTU measure 70 degrees? Now, you don't have to necessarily remember all the rules from geometry to do this in terms of the name. But we need to be able to look at a graph and determine what are angles as we look at problems with triangles. So try this problem. So there's one angle that's 70 degrees, it's equal to 110. 70 and 40 is 110, so that tells you that this angle is also 70. Now we know that vertical angles are equal, so that tells me that this is 70 and that this is 70. And if I have two parallel lines cut by a transversal, opposite interior angles are 70. Which tells me this is 70 and this is 70. And then I have my vertical angles again, so that tells me that this is 70 and this is 70. So I have 1, 2, 3, 4, 5, 6, 7, 8. So we need to understand all of those rules from geometry. Two parallel lines cut by a transversal. Opposite interior angles are equal. Two parallel lines cut by a transversal. Corresponding angles are equal. Two parallel lines cut by a transversal. This idea of vertical lines, vertical angles are equal. All those rules we need to be able to use. Now, solve a triangle, that's law of sines. I'm not going to go through that example here today. We want to look at law of cosines. Now, when do we use law of cosines? Well, if you remember, when we use law of sines, we have to have an angle and an opposite side to use law of sines, sine of A over A. However, if we had a triangle like this, we would not have an angle and an opposite side. There would be no way to solve that with the law of sines. And that's where we use the law of cosines. Now, here's the law of cosines. Now, there's three equations, but we only use one of them. And it depends what we're given. My triangle is not labeled. So if I labeled it angle A, angle B, angle C, I want to find angle A. I would now look at the top equation and say, well, I know B, I know C, and I know angle A. So if I labeled the triangle this way, I would use the first formula. If I would label my triangle differently, if I would label my triangle let's say BCA, now I know side A, side C, angle B, so I would now use the middle one. So it's the same formula is the point. These three, don't think of them as three separate formulas. Think of them as one formula depending on how you label your triangle. So I'm going to label my triangle now as CAB. B, trying to find side C. So that means I'm going to use the bottom formula, which says C squared is A squared plus B squared minus 2AB cosine of angle C. Biggest mistake people make here is they try to do all the addition and subtraction before they multiply. So you have to take 2AB times cosine of C. I like to do this by just going straight across the calculator, just typing the whole thing in, times 14 times 8 times cosine of 47. Make sure I'm in degrees mode. I am. So I just typed it straight across, hit enter. So C is 107.23, C squared, To find C, I just do second square root. I'm just going to do second answer. I'm not even going to type in 107. So now I got to take the square root of that answer, and I get 10.355. Now that we have used the law of cosines to find that side, we really don't have to use law of cosines again. Now, if I want to find these two angles to solve the triangle, at this point, it'd be much easier to go to law of sines and do the sine of B over 8, the sine of 47 over 10.355, and now do that like we did with law of sines. Take 8 sine of 47, divide by 10.355, and anytime I want to find an angle, I always have to do inverse. I get 34.43. And then if I wanted to find angle A, I can take that plus 47, subtract it from 180, and get 98.596. That's 59? 98. I don't know why I wrote 59. It was 98. When we do the law of cosines, we only ever really need to do it one time. Once we've done it that one time, we can fall back and use law of sines. So how do we know when to use the law of cosines and when to use the law of sines? Here's kind of a little chart that kind of shows you what to do. If you have a triangle where you know side, side, and an angle, and you know angle, opposite side, angle, opposite side, you could then find this angle, and in that case, you would use the law of sines. If you have side, angle, side, you don't know any angle on opposite side, this is a case where you got to use law of cosines. If you know all three sides, you don't know any angle, this will be a law of cosines. We haven't shown how to do that yet. We'll do an example of that in the middle. Here, angle, side, angle. Well, we don't have an angle on an opposite side, but if we know two of the angles, we can always find the third, and now we can use law of sines. Likewise here, angle, side, we can use the law of sines. So the only time we use law of cosines is when we do not have an angle on an opposite side. Side, angle, side, all on the same side. We don't know anything over here. Or you know the three sides. That's when you use law of cosines. Now, if we just know the three sides and we don't know any angles, we're going to pick an angle to try to find. I'll call this one A. BC. We're going to use this formula for law of cosines. And you realize we know everything but the angle. So I can say 5 squared equals 7 squared plus 6 squared minus 2, 7, 6 cosine of A. So now I need to solve, and I can kind of do this on the calculator and work through it. This would be 25. I'm going to subtract 49, subtract 36. This is a subtraction to get my answer. Then I'm going to divide by negative 2 times 7 times 6, and I get 0.7143. So that's cosine of A equals that. Now I can do inverse cosine, 0.7143, and we get 44.414 degrees. Now, once I've found out angle A, I now have an angle on the opposite side. I can now go back to law of sines to find my other two angles. All right, let's try this one. Let's go through it. We want to find angle A. So if I go through this, I have A squared equals 8 squared plus 15 squared minus 2 times 8 times 15 times cosine of 40 degrees. So A squared excuse me, 8 squared plus 15 squared, and it's not doing 8 squared, is it? 8 squared plus 15 squared minus 2 times 8 times 15 times cosine of 40. Take the square root of our answer. You get 10.25. What was it? 105.149 before we took the square root. So there's our A. Now, if you did this, okay, let's go through and say, okay, I now want to find side C. So if I find side C, I have the sine of C over 8 is the sine of 40 over 10.25. And if I do that, I get my sine is 30 point, I have answers up here, 09. And then if you do that and subtract it, you get your B to be 109.902. So this is, let's just say 30, 110, kind of round it off. Now, but here's the problem with that. If I would do this problem a little bit different way, if I would do this problem by saying, okay, let's find angle B first. And I do sine of B over 15 is sine of 40 over 10.25. I get B to be 70.098 degrees. So let's just round and say this is 70 and this is 70, or 70 and 69.9. So depending on which angle I do first, I could either get the blue to the left, or I could get to the green to the right. That doesn't make sense. I shouldn't be able to get two answers when I'm doing the same problem based on the order that I do it. So one of these is wrong. How do we know which one's wrong? Remember our check that we said early on. Look at the problem. The largest angle should be across from the largest side. The smallest angle should be across from the smallest side. And when you look at this, you can see that this one on this side is not correct. Now, why is that? Let me show you. A little on the calculator here. If I take the sine of 30 degrees, and then I do inverse sine of my answer, I get 30 degrees. Do the reverse. If I do the sine of 60 degrees, and I do inverse sine of my answer, I get 60 degrees. If I do sine of 80, and then I do inverse sine of my answer, I get 80. If I do the sine of 110, and then I do inverse sine of my answer, I don't get 110. I only got 70. So what's our problem? Inverse sine, let me write it back here. Inverse sine only gives answers to 90 degrees. You cannot get an angle over 90. So look at our example. Our angle B was 110. Inverse sine will not give you the answer. So if you try to go over here and find B, and I did this by doing sine of B, and then you have 15 sine of 40 all over 10.25, and then B is inverse sine of something. There's no way that will ever give you 110. It cannot give you an answer over 90. So how can we be sure when we do these problems that we're getting the right answer? We may be getting a wrong answer like we did on the right. Here's the key. Never use law of sines to find the largest angle. Let me say it again. Never use law of sines to find the largest angle. Never use law of sines to find the largest angle. Let's look back at our example here. As we look at this, you will notice over here, I found angle C first. I knew that was not the largest angle. How did I know that? Look at the sides. 10.25, 8, and 15. I knew 15 is the longest side. I knew angle B was the largest angle. I could not find angle B. I had to find angle C first. Over here, I have the same sides. 10, 8, 15. But I tried to find angle B, and it gave me the wrong answer. Never find the largest angle by using the law of sines. So, when you do a problem, such as this one, and I want to find A, and we say, well, A squared is 2 squared plus 3 squared minus 2 times 3 times 2 times cosine of 14. and we put that in our calculator. 2 squared plus 3 squared minus 2 times 2 times 3 times cosine of 14. And then I do the square root of that. Get 1.165. If I now want to find an angle with the law of sines, which is what I have to do, that's how we now find an angle, is using law of sines, I only have one choice. 3 is the biggest side. So B is the biggest angle. That means I have to find angle C. C is the middle angle because it's the middle side. So I have to find angle C. Don't find the largest angle using the law of sines. So whenever we do law of cosines, we do law of cosines one time, then we can revert back to what we already know how to do, which is law of sines. All right. Homework.